the previous tutorial, we see how LabOne Q can be a very powerful tool to describe your experiment in details and then make Zurich Instrument device execute it. However, it's not always obvious what the status of your device is by just looking at the code. This problem is especially harsh if you have a very large number of instruments and maybe even different tracks to control. Because of this, Zurich Instruments provides a rich set of tools in the form of UI to monitor what the status of your device is through a web app. Hi, I'm Emilio, and together we will see the QCCS monitor. In this tutorial, I will start from the documentation page of the QCCS monitor in LabOne Q. You can find the link in the description below. Now, I already downloaded the software on my device. It's basically just a folder. You can do the same to try it yourself by following this link. Let's try now just to run the basic command that it's present in the documentation. Now, I already opened a terminal in exactly the folder of the QCCS monitor. Now let's just run this command. I am asking the server to listen to the port 9000. I'm passing a REST directory relevant for the web application and then a configuration file called QCCS.json to pass the description of the rack that I want to describe. Don't worry too much about this configuration file, we will explore it a bit more in detail later. For now, you can already see that I am connecting to the data server and some of the devices that were present into this configuration were already found. Let's try to go to the web app. I am going to the localhost 9000 since I map it over here. We see that our QCCS is here present. And there we go. This is how our rack looks like. Now there are two LEDs on every one of each boxes. This green one that you see over here, it means that this device is actually connected. When a device is not connected, it would look like this gray box that you see here below for this HDWG and UHFQA. Then this LED on the left, which looks like a moon now, means the device is currently at rest. It's not doing any job right now. If I'm clicking on the PQSC, we can see, for example, to each port of the ZSync where a device is connected. And if I go more down, I will see that each one of the device has a complete report of its parameter. For example, the modulation of the oscillator, the source of the reference clock, and so on. Let's move, for example, to the SHFQC, and let's try to run some simple experiment to see how this device would change in real time following the status of the device. Now I'm going back to my notebook, and I am running an experiment that we already ran previously in another tutorial, a 2D sweep in both frequency and power. Basically, we are changing the frequency that we are sending to a resonator and at the same time the power that we send to the resonator. So we should see both of these parameters changing the QCCS monitor. Let's just try to run it and go back to the QCCS monitor now. Now I am looking mostly at the digital oscillator offset frequency and the power, since these are the two things that I expect to change. As you can see, as the experiment goes on, these parameters are changed and are correctly reflected on the QCCS monitor. At the same time, since our SHFQC is doing some job, you see that our device is actually changing the LED from the moon to this green status button. The same is happening from the PQSC, since we are using it to send the trigger command to the SHFQC. If everything looks a little bit like magic right now, it's because a bit of the complexity was hidden inside the configuration file. Namely, what kind of device we want to address and how the rack would look like in our web app. So let's try to dig a bit more into the details of how this works. So I move into my configuration file and you see how it looks. We are passing the data server host using this host keyword, the port of the data server, and this log is just the name that we want to give to this specific setup that we are building. Then we can start building racks. You can build the different racks under the same slug, and we will do it in a while, but first let's try to add another instrument to our toolkit. You are passing through the 8-bit keyboard how you would like to be the box. For example, we could try to make the SHF boxes a bit larger, as they are like this in real life. Also, I realized that I missed an SHFSG before, so let's add this to the list of the instrument that we have over here. I want it to be of the same dimension of the other SHF devices, and this is actually an SHFSG8, and its device ID is 12050. The device ID is what the QCCS monitor will use to address the device, so be particularly careful about this. We can also build different rack in case we have one in our device, in our setup. So let's just build one more rack. For simplicity, I will just copy paste this one. And there you go. Now we have two different racks which have exactly the same instrument. Of course, in a real case scenario, you might want to change the name of the instrument to reflect the one of your new rack. So now that we changed the configuration file, let's see how the web application looks like. I just ran exactly the same command, but now the configuration file is different, and you see that they already recognize the SHFSG that we just added to the configuration, the device 12050. Now if we move to the web app, see that now the two racks are present. In this case, they are exactly the same, but in your case, they could represent two different physical racks in your setup. Also, the dimension of the boxes of this SHF are now bigger as we pass the command to do so. Now we can just click on any of these devices and then immediately be presented with its current configuration. As this is a web app, it can be very easily accessed also remotely, for example, if you're home and you want to quickly check what the status of your device is. Thanks for tuning in to this tutorial. If you have more questions, feel free to contact us at any time. You find all our contact information in the description below. See you in the next tutorial of LabOne Q.